dive right into this explainer. We're going to decode the exact engineering required to build a solid strip foundation literally from the ground up. You know, whenever you walk into a sturdy brick building, you're actually standing on top of some pretty incredible hidden geometry. It's a structural system perfectly designed to transfer massive weight safely into the earth. So today, we're stripping back the dirt and concrete to look at the real anatomy of that stability.
We're pulling all our precise measurements and structural relationships directly from a dense technical blueprint by Chirangamana Integrated. And what we're doing is taking this highly detailed schematic and transforming it into a step-by-step physical build. It's awesome, because you'll see exactly how dry engineering math becomes physical reality.
Okay, here's our agenda. We have 6 phases. 1. Digging the perfect trench. 2. Pouring the concrete footing. 3. Building the foundation wall. 4. Prepping the sublayers. 5. Installing the moisture barrier. And 6. Pouring the concrete slab.
Starting off with Section 1, digging the perfect trench. The absolute foundational number we need here is exactly 690 millimeters.
Now, what's really fascinating here is seeing that massive 690 millimeter trench width spread out at the very base of the excavation. It's definitely not arbitrary. The engineer specified this width to give us an equal foundation spread on both sides of where the future brick wall is going to sit. This ensures the ultimate load of the building distributes perfectly evenly into the earth. And once dug, the sides get supported by backfill using excavated soil and other approved materials.
Moving on to Section 2, pouring the concrete footing. For this step, the magic number for our concrete strip footing's thickness is exactly 230 millimeters. So, the crucial point here is the math. It's actually a beautifully simple equation. A 230 millimeter foundation wall resting on a 690 millimeter wide footing means the wall is exactly 1/3 of the footing width. That elegant 1:3 ratio, that is a literal pillar of structural integrity.
Zooming in on the base, check out this 230 millimeter thick concrete footing poured squarely into the earth. The blueprint specifically notes this has to be poured to a specified density, strength, and ratio of cement-sand mixture. It's not just a mud slab, right? It's a meticulously mixed chemical anchor forming the ultimate base for the whole structure.
Section 3, building the foundation wall.
This perfectly illustrates that 1/3 ratio we just talked about in action. You've got the 230 millimeter industrial brick and mortar wall sitting completely centered on that 690 millimeter footing. Because it's perfectly centered, we get that equal foundation spread on both sides to balance the weight flawlessly. And they don't just stack bricks, they use a specified cement-sand-mortar ratio and reinforce it with brick force, which is a hidden steel wire mesh at standard intervals to keep everything locked tight.
Next up, Section 4, prepping the sublayers.
Before you can even think about a floor, you have to prep the space inside the walls. First, the topsoil is removed to create a reduced ground level. Then for step 1, we drop in 150 millimeters of well-compacted hardcore, basically broken bricks and approved material to fill the void. Step 2, we cap that jagged hardcore with 40 millimeters of sand blinding to act as a smooth, protective cushion. You can really clearly see how these sublayers stack up here. Sitting just above the reduced ground level, that chunky 150 millimeter hardcore is doing the heavy lifting, and it's instantly smoothed out by the 40 millimeter sand blinding layer right on top of it. It's the perfect bed for the next phase.
Which brings us to Section 5, installing the moisture barrier.
This is where we bring in the DPM, or damp-proof membrane. Honestly, think of this as the unforgiving bouncer of the construction world. It's a heavy-duty black polythene sheet that creates an impermeable barrier, and it stops ground moisture dead in its tracks, so it can't rise into your concrete or brickwork. Check out how the DPM is actually placed. It doesn't just lay flat, it's strategically laid right over the smooth sand blinding, and then it snakes vertically upward directly between the interior brick wall and where the concrete slab will go. This continuous envelope means moisture literally has zero pathways upward. Finally, Section 6. Pouring the concrete slab. The final piece of this puzzle is a 100 millimeter cured concrete slab. But again, it's not standard concrete. It uses a very specific cement-sand mixture for strength, and it is internally reinforced with mesh wire so it can handle heavy foot traffic and structural loads without cracking. The alignment here is absolutely crucial. Notice how the 100 millimeter slab sits directly on the DPM.
And importantly, it sits securely adjacent to the brick wall. It does not rest on top of the wall. It also finishes perfectly level with the brickwork. And, looking at the big picture, the top of the foundation wall and the slab both sit comfortably above the natural ground level, or NGL, by up to 150 millimeters. This elevation is your ultimate defense against water getting in from the outside.
Putting it all together, the complete cross-section is pretty amazing. From the massive 690mm trench base distributing the load, up to that perfectly centered wall relying on the 1/3 ratio, the 150mm of hardcore, the 40mm of sand blinding, the DPM all the way to the 100mm slab finishing above the natural ground level, this is how perfect structural integrity is engineered. Every single line serves a vital purpose.
So it leaves you wondering, right? If a builder decided to cut a corner and ignore just one of these precise ratios, say they didn't respect that 1/3 wall to footing spread, how quickly would this entire anatomy of stability just crumble beneath our feet? The tiny margin between a structure that stands for centuries and one that fractures in a year is written right there in the math. Definitely something to think about the next time you step onto a solid floor.